Last section of material, section 5.2, we're going to extend what we did in section 5.1. So in section 5.1, we had systems of equations where we had two equations and each of them had two variables. So in this lesson, we're going to have three equations in most cases and three variables. So taking a look, we're going to just talk first about solutions. Solutions work in practically the same way that they did before. I have an ordered triple now, though. I have an x and a y and a z, and I have three numbers, and I'm going to decide whether or not it actually satisfies all three equations. Be very careful when you're writing your z's to make them for sure look like a z and not like a 2. Z's are tricky like that, so I'll put lines through the middle of mine. You can do whatever you need to do. Just make sure it's clearly written so that I don't have to do any guessing work and you don't confuse yourself by looking back at it later and not knowing for sure too. So on this one, they always put them in order. It's alphabetical, X, Y, Z, okay? So we're trying to decide if this ordered triple works in all three equations. So my first equation is X plus Y minus Z equals 0. So if X is -2 and Y is 5 and Z is 3, do those, in fact, all add up to 0? They do. Now, it's actually counterproductive, not counterproductive, but not happy. You should be not happy when it adds up and it works. You know why? Because if it didn't work, you'd be done, and the answer would be no. Because it does work, you got to do the next one. So we go on to equation number 2. So I'm just going in order, calling them 1, 2, 3. We'll do that repeatedly today. So equation number 2 is 3x minus y plus 3z equals -2. So again, x is supposed to be -2, y is supposed to be 5, and z is supposed to be a 3. So we're going to just multiply these out. So I have 3 times -2 is -6. I have a -5 in the middle, and I have a +9. So check for me. -6 minus 5 plus 9, does that equal -2? Yes, which means we have to do the third one, right? Again, if it didn't work, we would stop. We'd just say the answer is no. X plus 2y minus 3z equals -1. So x is -2, y is 5, z is 3, equals -1. So I have -2 plus 10 minus 9. Does that equal -1? Yes, it does. So all of three worked, which means that this is in fact a solution to the system of equations. Now, that may not be the only solution. We don't really have the ability right now to say it is or it isn't. Oftentimes it is, but we will look more later on at that issue at the very end. So any questions on checking solutions? It should feel just like the other ones that you did back in 5.1. All right, so let's actually get to how it is we go about solving a system with three variables and three equations, generally three equations. It says you can use the addition or the substitution method. And it's a true statement. You can, but we're going to be using the addition method. And to be honest, the reason is because it's cleaner. It's easier to work with. It's more, not precise, but it's more concise. So it's easier to work through. So we're going to be using the addition method. Basically, we're going to take three equations and we're going to pare it down into two equations. And then we're going to have two equations with two unknowns, and we'll do it just like we did in section 5.1. Okay? So eventually it all falls out and it looks like we did what we did before. You can check your solutions to every single one of these problems just like you could in section 5.1. So if you get to the end, you can check it just like we did on problem number 1 here, right? And make sure it works in all three of your equations. So that's always a nice feature of this last sections of material. All right, so we're going to practice. We're going to do 3 separate examples of very much the same process to give ourselves a handle on this idea. Much like with the material in section 5.1, we get to make choices along the way. Sometimes there's an inherently easier choice, and sometimes there are just equally easy or difficult, whatever your perspective would be. But our goal is to pick one of the variables, either x, y, or z, where it's easy to make the coefficients match. That's really what you want. Maybe they already match, or maybe it's just easy to change something to make them match. So sometimes, again, like I said, there's an easy choice, and sometimes there's simply easy choices all the way around or hard choices all the way around. So we need to pick a variable. I'm going to call my equations 1, 2, 3. You do not have to label your number, or number your equations. But I think that if you make mistakes, you're going to find it easier to go back and track through where your mistakes came from or how to fix them if you do have them numbered. And it certainly will make it easier for me to grade and the grader to grade as well. So taking a look at these, I'm open to suggestions. Do you guys want to eliminate x, y, or z? X. Okay, so Bailey says x, so we're going to eliminate x. So these are going to be my goal, is to eliminate. Now, the reason I say on this one particularly that it kind of doesn't matter is because in every equation we do have one variable that has a coefficient of either 1 or -1. So it kind of doesn't matter what we eliminate on this one. Any of the choices are going to make it pretty much the same process in terms of easy or difficult processes. So we're going to go with eliminating the x. So if I take equation number 1, which is 4x minus 2y plus z equals 13. I'm going to pair that with equation number 3, okay? Because equation number 3 is the easy one to manipulate so that it will have the same coefficient in front of x. What would I need to multiply by to get rid of that value? Yeah, I would need to multiply by -4. So I'm going to take equation 3. Again, I'm labeling mine. I'm going to multiply it by -4. So now I have -4x. I have to do every piece, so -12y, positive 12z, and positive 40. Okay, kind of got some bigger numbers toward the end there. So again, the goal is to eliminate a variable, which we did. We eliminated the x. In the middle here now I have -14y, I have positive 13z, and I have 53. Everybody good with that? Now, in a moment here, I'm going to give this equation, because it is one of my new equations that I created a name. I'm going to call it equation 4. If you want to label it now, you can. I'll wait on mine for a moment. But my goal is to create 2 equations with 2 variables, and I've done that. I've created 1 equation anyway with 2 variables. So now I need to choose either equation 1 and equation 2, or equation 2 and equation 3. I have to use one of the equations I already used and the other equation, number equation 2, that I didn't already use. Which 2 are the easier to pick? 2 and 3, right? Because it's easier to, again, I still have to eliminate the same variable. I can't go changing my mind now and eliminate y's. That's not going to work. I still have to eliminate x's. So let's take equation 2. So equation 2 is 3x minus y plus 2z equals 13. And then what will I need to multiply my equation 3 by to get the coefficient x's to match? Yeah, -3. And by match I mean to have the same sign, different signs but the same value. So -3x, -9y, and then I have positive 9z, I believe. Did I? Yep. And then it equals 30. Okay, so far so good. So now we're going to add these together. So this adds to 0. I have -10y. I have positive 11z. And it equals 43. So like I said before, I've created 2 equations. I'm going to call them equations 4 and 5. And I'll write them more concisely up here. I'll put it in this black spot at the top. Equation 4 and equation 5. So equation 4 is -14y plus 13z equals 53. And then I have negative 10y plus 11z equals 43. Is it 43? Yeah. Okay. Now, these are not nice equations. I mean, they just aren't. So it's possible that if we eliminated y or we eliminated z, that we would end up with nicer equations at this point. But there's no way to anticipate or to know that that's going to be the case, just FYI. So we deal with where we are, and it'll be okay. Obviously, none of these match up perfectly, and my numbers are going to get a little bit larger, but y'all got a calculator, and your calculator can handle that, no problem. So right now, none of my y's or my z's are friendly. Which one do you want to eliminate? And it sort of doesn't matter. Z's. Okay, let's eliminate z. So they have the same sign, which means one of them needs to be multiplied by a negative. I'm just going to choose the first one. And 13 and 11 don't have anything in common, so we're just going to multiply them by one another. So the first one will be multiplied by 11, negative 11, and the second one will be multiplied by 13. Okay, is everybody with me on that? Okay, we're just going to cross our fingers that we get all of our numbers right as we go. So equation number 4, let me grab a calculator out too. We're going to multiply through by that negative 11. So the first number becomes 154, and it is positive, so 154y. 13 times 11 is 143, so negative 143z. And then 11 times my 53 is 583, and it's negative. The next one is negative 130y. I have that same 143, but now it's positive z. And then 13 times 43 is 559. What's that? Oh, it's a delay in our Wi-Fi, but it showed up. Okay, so if my calculator multiplied something wrong, now is definitely the time to tell me. Okay, is that all right? Everybody good? Trust me when I say it will clean up nicely in almost every case. These problems are created to give you some pretty nice values, typically speaking. So obviously the 143AZs go away. At the beginning, I have 154 minus 130, which gives me what? 24y. And then over here on the right-hand side, I have negative 583 and positive 559, which gives me another negative 24. So yes, in fact, I'm going to have some lovely numbers because I'll divide by 24. And even though it was a messy process getting there, y is negative 1. Okay, is everybody good so far? Okay, so this is one of the 3 variables that I have found. I need to find all 3 of them. So I sort of work my way back up the bunny trail, all right? So I need to go back one step, which is to equations 4 and 5, before I multiplied by the large numbers, but equations 4 and 5. Because equations 4 and 5 had y in them, but they only had one other variable in them. So if I use y is equal to negative 1 in equation 4 or equation 5, I should be able to find what z is without having any other variables involved. It doesn't really matter which equation you use because they're both kind of ugly, to be honest. I'm just going to use equation 4, but if you want to use equation 5, that's totally fine. So in equation 4, I have negative 14y plus 13z equals 53. And y is negative 1. So negative 14 times negative 1 plus 13z equals 53. This is 14. So I'll subtract 14 from both sides. As I do that, my 3z will now equal 39. I'm sorry, my 13z will equal 39. And what will I need to do? Yep, divide by 13. So if I divide by 13, then z is going to equal what? 3. So this is my second value that I've now found. So found y, found z. Now I can go back into equations 1, 2, or 3, where there's x, a y, and a z. And there is a choice that's nicer than the others on this one. Which choice is the nicest one to evaluate into? 3. And the reason is because the coefficient in front of x is 1. So I'm going to use equation 3. If you use one of the other ones, will you get the same answer? Absolutely. You'll just have to do a little bit more work to get it. So x plus 3y minus 3z equals negative 10. X is what I don't know. Y is negative 1. And z is 3. So I have x minus 3 minus 9 equals negative 10. What is negative 3 and negative 9? Negative 12. So x minus 12 is negative 10. If I add my 12, what will x equal? 2. So the solution then is the ordered triple. Always should be written as a triple. X, which is 2, y, which is negative 1, z, which is 3. And that's our solution to the problem. All crammed down there in the corner. Sorry about that. Okay. We're going to do another one. You ready? Okay. The goal is to practice so that you can see how things work out nicely sometimes and maybe not as nicely. So that first one was kind of messy. The second one I think will be a little bit more straightforward. So again, our goal when we look at our equations is to decide what variable is going to be the easiest to eliminate. And sometimes the answer, like on the last one, is it doesn't really matter. But sometimes there's definitely a better pick. There's a better pick on this one. What variable is going to be the easiest to eliminate on this particular set? Z. Z is amazing because all the coefficients are 1, right? Some are positive, some are negative, but they're all 1. In particular, if I take equations 1 and 2 and I add them together as is, what's going to happen? Yeah, the z is going to cancel itself out without me even having to really do a lot, you know. So we have this going on for us, negative 5. So yes, the z's cancel. X and 2x is 3x. Y and negative 2y is negative y. And then on the right-hand side, I have a 1. This will be equation number 4. Okay, I need to use equation number 3 as well now, but do you want to pick equation 1 and 3 or 2 and 3? 1 and 3? Okay, so if I pick equations 1 and 3, much like picking equations 1 and 2, I don't have to do anything to get the coefficients to cancel out, right? I had to just use them as is. X plus y plus z equals 6, and 3x plus y minus z equals 2. So once again, the z's add to 0. I have 4x plus 2y equals 8. We can call that equation 5 and leave it there if you wish. Or you could and might happen to notice on this one that all the coefficients on this one are even. So if you wanted to, you could divide everything by 2 at this point and use that as equation 5. I'm just going to leave it. But sometimes it's 5. Sometimes it is preferable to reduce things and get them to be smaller. We saw what happened on the last one when the things couldn't be reduced and they had to stay large, right? Got really messy and really ugly. So oftentimes you might want to go ahead and reduce things because it might stay smaller if you do. On this one, it doesn't really make any difference, so I'm just going to leave it. So these are my equations 4 and 5. So I have equation 4. I'll put it up here at the top as well. And then I have equation 5. Okay. So we get to pick. What do you want to eliminate? Which variable?
If you reduce it, the y's cancel out already.
They do. So if you reduce it, the y's are going to cancel out immediately. If you don't reduce it, what would you do to get the y's to cancel out? You can multiply top equation by 2. So you basically end up having two choices. You're exactly right, Zane. You can either divide equation 5 by 2 and they'll cancel out immediately, or you can multiply equation 4 by 2 and they cancel out immediately. So that's why I said on this one it doesn't really matter, because you're kind of in the same position either way. So your choice, either divide equation 5 or multiply equation 4. Because I already wrote mine, I'm going to go ahead and multiply equation 4 by 2. So equation number 4 becomes 6x minus 2y equals 2. And equation 5, which will stay the same, is 4x plus 2y equals 8. So these cancel, right? Either way, whether you reduced equation 5 or multiplied equation 4. And you will get, in this case, 10x on the left and 10 on the right. If you had done the reducing, the numbers would be slightly different, but when you divide, you'll get x equal 1 either way. Didn't mean to do that. Highlight it. Okay, x is equal to 1. So working our way back upward, we go now back to equations 4 and 5, the last place we had equations with two variables. Do you want to use equation 4 or equation 5 to find the missing variable? Which one? 4. Okay, so if we use equation 4 says 3x minus y equals 1. So if x is 1, so 3 times 1 is 3. So you can probably just do this in your head, to be honest. What would y have to equal? 3 minus what is 1? 2. If you didn't want to do it that way, you can subtract the 3 and divide by the negative 1. That's fine as well. But either way, you find out that y here is 2. That's what has to work. So that's what it has to be for it to work. So we've found x, we found y, we need to find z, which means we need to go back to either equations 1, 2, or 3. Again, we have a choice, and we get to pick equation 1. Equation 1's a little bit nicer because the z is positive, so I agree with that. We have x plus y plus z is equal to negative 5. So we had x is 1, y is 2. What's that? Did I write down wrong? Oh, I did. Thank you. 6. And it equals 6. So I have 1 plus 2 plus what does z have to be for this whole thing to equal 6? Z would have to be 3. So my answer as an ordered triple is x is 1, y is 2, and z is 3. All good? Okay, we're going to try one more for practice, and then we're going to shift gears slightly. All right, equation 1, 2, 3. What variable would you like to eliminate? Why? Bailey's picking all our variables to eliminate today. Why not? Okay, y is good. We can eliminate y. So we need to take a couple of equations where y eliminates, either easily or that we can change it to something eliminates easily. 1 and 2 are very nice because they have the same coefficients with opposite signs already. So I have x plus y plus z equals 9. And then I have x minus y plus 2z equals 1. So if I add these together, the y's cancel. So I have 2x plus 3z equals 10. So this will be equation number 4. Okay, so I know I need to take equation 3 because I haven't used it yet. Do you want to do 3 and 1 or 3 and 2? Corbin says 1. 3 and 1, or, oh, I think maybe 3 and 2, actually. If I do 3 and 2, then they actually line up with the signs opposite. Let's do 3 and 2 on this one. So we'll do 3 and 2. So we have equation 2, equation 3. So equation 2 is the one I just did, x minus y plus 2z equals 1. And equation 3 is x plus y minus z is equal to 5. So it's worth noting that each time where we've had a choice and we've made that choice, if you make a different choice and solve it using a different set of things, you'll get the same answer, provided you're making all the right moves, of course, along the way. But the order you pick does not make any difference in the solution that you get. So on this one, of course, the y's eliminate, but you do need to eliminate the same variable in this first 2 steps here. You have to do both the same variable each time. So this is 2x now, plus z equals 6. And this one would be equation 5. So I've got equations 4 and 5 now, and we're going to have to pick a variable to eliminate. So what variable would you guys like to eliminate on this one? Somebody besides Bailey. She keeps picking all my variables. X? Okay. Now we can't just move forward then, right? Because the x's are the same, but they'd have the same sign. So what am I going to have to do in order to get them to not have the same sign? Yeah, I need to multiply one of them, and it doesn't matter which one, but one of them by -1. I'll do equation 5. So equation 4 stays the same, 2x plus 3z equals 10. And in equation 5, I'm going to make them all negative. So negative 2x, negative z equals -6. So 2x minus x, that one's going to be the 0, of course. And then my z's are going to give me 2z equals 4. What's z going to be? 2. Yes, ma'am. Z's 2. All right, working our way back up. It doesn't matter which one we pick, x or, 5 or 4, because they're exactly the same in terms of their coefficients, so I'll just pick 4. I have 2x plus 3z equals 10, and I know z is 2, so I have 2x plus 3 times 2 equals 10. 2x plus 6 equals 10. So if I subtract my x, 2x is 4. What will x be? Yep, another 2. And then our last step is to go back to equations 1, 2, and 3 to solve for our missing variable, which in this case right now is y. So it really doesn't matter a whole lot. I'm just going to pick the first one. So if I pick equation number 1, it's x plus y plus z equals 9. X is 2. Y I don't know. Z is 2 equals 9. What would y have to be to make all that equal to 9? 5. Yep. So that's my third one. So my ordered triple is x is 2, y is 5, z is 2, and I'm done. Any questions on those? Okay, we're going to shift gears slightly on the next problem. Ignoring the directions for the moment, I just want you to look at the system and tell me, what is it about this system that makes it different than the problems we just worked with? There are only 2 equations, but there's still 3 variables, right? So this isn't like what happened in 5.1. In 5.1, we had 2 equations, but we had 2 variables. Here we have 2 equations, and we have 3 variables. Now the direction set asks us to do a couple of things. It asks us to find 3 solutions, And it also asks us to write the solution set in this funny sort of form right here. So we're actually going to follow the directions, but we're going to do them in reverse order. It is a lot easier to figure out a solution, right? We have to find 3 of them if we've figured out the general form first. Lots easier. Otherwise, you're random guessing and checking, and you could be at that all day. That's not a good idea. So there is one additional thing that they tell us here that you might not have sort of picked up on. They tell us that z is going to be unknown when I write my general situation. What that means is that although it might be nice, depending on the equations I'm given, I'm not going to eliminate z. Okay, so I'm never going to eliminate z in this particular direction set because z is part of the arbitrary I don't know solution set. So what does that mean? Well, in one case, I'm going to eliminate x. And then in a moment after that, I'm going to eliminate y, but I never eliminate z. So let me show you how that works. So if I'm eliminating x, I need them to have, I mean, there are only 2 equations, right? I don't have to worry about selecting anything. I'm just selecting the 2. If I'm trying to eliminate x, I need them to have the same coefficient. So 2 and -2 would be good choices. So the 2 is already there, and I can multiply the second equation by -2. So equation number 1 is 2x minus 3y equals -9. And on the second equation, I'm going to multiply by -2. So -2x, -2 times -y is positive 2y. And it equals -6. Okay, is everybody good so far? So I'm trying to eliminate x. That is my goal. I am successful because those add to 0 now. That leaves me with a -y. And I'm sorry, I should have had those z's still in there. I don't know why I didn't write them down. My bad. Go back and put the z's in. So sorry. There's a -z here and a positive 2z here. It's like, where'd my z's go? All right. So I have a positive z here and -15. Okay, once you got your z's back in, is everything okay? Okay, great. The goal is to solve for y. Okay, I'm not going to eliminate z's. I'm not doing anything with the z's. There's z is going to be in the answer. I just needed to say y equals when I'm done with this step. So I'm going to move the z, so -z. So now I have -y equals, you can either write -z minus 15 or -15 minus z. It doesn't make any difference. And then, of course, I'm going to solve for y, which means I need to either multiply or divide by -1. So if I do that, what I would have just found out is that my solution, if you can call it that kind of, for y, is that y is equal to z plus 15. All the signs switched because I divided by a negative. Okay, we'll come back to that in a moment. Just hold tight to that, and we're going to move to step 2. Step 2 looks just like step 1, but instead of eliminating x, I'm going to eliminate y. So looking at the y's, I would need to multiply my second equation by what?
3.
Yep. -3 will do it. Yeah, so we've eliminated, I'm going to move this up because I'm going to need some more space anyway. So I have 2x minus 3y minus z equals -9. And then I'm going to take my second equation and multiply by -3. So -3x, positive 3y, positive 3z equals -9. So in doing so, the y's eliminate, right? On my x's now, I have -x. On my y's, I have positive 2z. I'm sorry, my z's, I have positive 2z. And on the right-hand side, I have -18. Okay, again, so far so good. goal is to solve for x, right? Everything's going to still have z in it when we're done, so I'm going to subtract my 2z. I have negative x on the left. And again, you can write it in whichever order you'd like, either the negative 18 first or the negative 2z first. I usually put my variables first, so I'm going to go with negative 2z minus 18. And then we divide by negative 1 so that we can isolate x itself. And we find out that x is equal to 2z plus 18. Or 18 plus 2z if you prefer. So, what does that mean? Well, it means I can take this ordered triple notation that they gave me at the beginning, and I can fill in the blank for the x and I can fill in the blank for the y. They already filled in the blank for z. It's just z. So my ordered triple, as odd as it might feel to write it down this way, is 2z plus 18, comma, z plus 15, comma, z. That's my ordered triple. It's weird, right? Now, we didn't actually answer the first part of the question. We've answered the second part. We've found this random ordered triple that has z's all in there still. I mean, like, that's what we found. So what do we do to answer the part of the question that said something about, like, finding 3 solutions? Well, take a look. You know what? I'm going to do this. I'm going to copy this to the next page. I think there's space. There's definitely not. All right, well, let me copy it up here anyway so I can see it better. This is my ordered triple. It's on the top of my screen now. What this says is that you can pick the value for z and solve for everything else. And you can pick anything for z you want. Don't be too creative. Be boring. Okay? It's easier to grade if you're boring. Pick z equals 0. Pick z equals 2. Pick z equals 5. Do not pick z equals 573,298. It's not a good plan. Okay? So if I pick z as 0, I kind of like zeros. That's me personally. Then I go back and I use 0 inside where the z is in each of the other pieces. So if z is 0, 2 times 0 plus 18 is 18. And if z is 0, 0 plus 15 is 15. Right? That's a solution. It's not the only solution, right? We talked about that at the very beginning, that just because I find a solution doesn't mean it's the only solution, but it is a solution. I can actually choose something else now, too. Maybe I pick z is equal to 1. Okay, so what happened if z is 1? Well, 2 times 1 is 2, plus 18 is 20. 1 plus 15 is 16. Okay, maybe you feel a little adventuresome and you want to make z negative. So you say, let's let z be negative 2 or whatever. Well, we're going to have negative 2 at the end. So you have negative 2 times 2 is negative 4. Negative 4 plus 18 is 14. Negative 2 plus 15 is 13. So there are infinitely many things you can pick at this point, but they do still have to actually all work. Okay, so this is generally how these problems work out. I want to show you one specific more example where you can see something a little bit funny happen, because funny things can happen sometimes too. Okay, the direction set is exactly the same. I didn't rewrite it on this screen, but it's the exact same direction set. We're going to find 3 solutions. We need to let z be z, all that stuff. Okay, all those things are going to be the same. So on this one, we need to attempt to eliminate x. And then over here, we would try to eliminate y. But there's going to be something a little bit different that's going to end up happening. What happens, do you notice, when you eliminate x on this? Yeah, other things are automatically eliminated. So if it automatically is already the same. So negative 2x plus 2y minus z equals 4. And I have 2x minus y plus z equals 1. And these eliminate right here, so then I have 1y. And what happens to the z's by just sheer luck on this one? They cancel too, right? So that's a little weird, but it's okay. What it actually means is that the y value does not depend on z in this case. And in fact, over here where we had lots of things that we could pick for x and y and z, we don't here. Y is always going to be 5. So when I create my ordered triple, I'm not going to have something in the middle, that second term that has a z in it. It's just going to be 5, just like it was when we were finding the earlier ones. Now I need to eliminate y. So let's come over here to eliminate my y. So what will I need to do with these two equations then to eliminate y? Right, multiply the bottom by 2. So the top one will stay the same, negative 2x plus 2y minus z equals 4. And I multiply the bottom equation, like you said, by 2. So I have 4x. I have minus 2y, which is going to allow me to eliminate it, and then plus 2z equals 2. So these add to 0. The z doesn't disappear this time, right? It disappeared on the last one, but it doesn't disappear this time. So on this one I have 2x's left, I have a z left, and it equals 6. So we're going to solve for z. We're going to subtract our 2x. I didn't say that right. We're going to solve for x, which means I'm going to subtract my z. So I have 2x equals, and I'm going to put it as negative z plus 6. If you want to do 6 minus z, that's fine. And divide by 2. So x is equal to either negative z plus 6 or 6 minus z over 2. So, on this one, my ordered triple is negative z plus 6 over 2. 5. That's weird, but that's okay. That's what it is. And z. This is my general form. But it happens to have one of them that's always 5. But I do the same thing for the other 3 answers that I'm supposed to pick. I pick what I want z to be. You want z to be 2. Okay, so one option is, I've got a 5 here, is for z to be 2. So if z is 2, I have negative 2 plus 6, which gives me 4. 4 divided by 2 is 2. So one of my options is 2, 5, 2. What else would you guys like to pick for z? How about 0? Can you guys let me pick 0? I like zeros. Negative 0, or 0 plus 6 would be 6. 6 divided by 2 is 3. And then watch this. I'm going to pick one more just because I want to show you something kind of nice. This is how much I like zeros. I'm going to pick 6. So now I have negative 6 plus 6, which is 0 on top. Yeah. 0 divided by 2 is 0. So I get another thing with 0 in it. It doesn't matter which you pick. It's completely irrelevant. Just pick some values for z, find the value for x that corresponds, and they'll be good to go. Any questions on that? All right.